Good afternoon, ladies and gentlemen. My name is Mr. Luchwager, and for Upward Bound, I teach chemistry and physics. And today, what we're going to be doing is we're going to be taking a look at some of the science behind some of the things that we can find in our home, particularly fireworks. This is a great example to use to take a look at the science behind a lot of different concepts and ideas that deal with chemistry, momentum, equal and opposite reactions, color emission, and so much more. So we're going to take a look at some of these today and see what we have. Before we get started today, I just want to point out that we are practicing good lab safety, even though we are at home. I've got my safety goggles on, and they protect my eyes from anything that could potentially get in there. I have long sleeves on, but they're rolled up, and any watches or jewelry that I have are also secured so they don't slide forward. If I were to have long hair, it would be tied back and secured, and my safety goggles have some extra string here that holds them tight, so I'm tucking that in so that doesn't fall in and become a fire hazard. Also, for ignition purposes, I'm just going to be using a stick lighter. Makes things a little bit easier and a little bit more convenient on safety-wise. The first one that we're going to take a look at today is the sparkler. The sparkler uses a chemical reaction known as the combustion reaction, in which oxygen and a substance burn, and as this substance burns, it releases energy in the form of light, heat, and sound. As the heat is produced, it sparks, and as the light is produced from the reaction, what we see is electrons jumping from one energy level up to the one above. As these electrons start to fall, they release energy as photons. And in sparklers, in this case, they use sodium, and we see orange sparks and maybe even an orange flame. Some of the other common elements that we're going to see if we were to do this at or watch fireworks during the 4th of July would be copper, would be green or blue-green. We would see potassium, which would be purple or red. Lithium is yellow, and many, many more. That is just one aspect of what we're going to see here. Okay, so right now we have a sparkler going. You can see that it is emitting orange sparks, which is the presence of sodium. As the sodium undergoes the combustion reaction, those photons are being released as the electrons fall down from one energy level to the one below it. So they jump up, gain that extra energy from that, and then they fall back down and release that energy as light. And also, if we listen closely, you can hear some sound as well. Next, we're going to take a look at this little tank. This tank gets lit on one end. Once it gets lit, the gunpowder starts to burn and starts to provide thrust, which moves the tank forward. Now the tank is experiencing different forces, friction, gravity, and the force is going to be enough to overcome the force of friction, and it's going to move forward. Eventually, as the amount of friction increases between the wheels and the concrete, or the surface that it's traveling on, the friction will overpower the movement, causing it to stop. Then we'll also see the different reactions that provide the colors and the little different explosions. Next up, we have the tank. If we take a look, you can see the pink area where the gunpowder is. And what happens here is we'll provide the ignition. Once the ignition gets going, it's going to create a chemical reaction, which then is going to create thrust, which is going to cause the tank to move forward. Friction with the concrete is what's going to cause the tank to move, and eventually that friction becomes too much for the tank to overcome, and it will slow to a stop. Once it slows to a stop, it should connect with the other portions that should ignite and should show us a shower of sparks. So let's see what happens. That was really loud, and there was some flash and some bangs in there, and that big yellow or orange bang was sodium chemicals that were being exposed to a chemical reaction and causing that to go off. If you've noticed, sodium is pretty common in these chemical reactions because it is readily available and fairly cheap to put into these chemical reactions. Next, we have these little cake fireworks called Medusas, and they're going to produce showers of sparks, and we should be able to see those different colors from the chemical reactions and the combustion reactions of those different elements. And with each color that's produced, it's a different element that is experiencing the electrons going up to the next energy level and then dropping back down and releasing that energy as photons of light. As you can see in this firework here, the Medusa, we're producing big ash snakes, and that is a chemical reaction in which precipitate forms, where you usually have two substances and they come together to make kind of a semi-solid substance. So in this case, they make these snakes, and at the beginning you could see some red and a little bit of orange, so there was some sodium and lithium or potassium in this reaction. And then finally, we're going to take a look at these little champagne poppers. These champagne poppers have two cardboard discs on them. One cardboard disc is in the front here that holds everything in, and then one is going to be up here on this top level here. And that seals everything together, the confetti and the streamers. And then in the neck here of the little bottle, there is a little charge. In fact, it's less than 1 milligram of gunpowder. And when this cotton string is pulled, it produces enough friction to ignite the gunpowder, which then causes a chemical reaction and combustion, which causes a little explosion. And this here we'll be able to see Newton's laws of every equal and opposite action has an equal and opposite reaction. That's what we'll see there. And then last but not least, if we take a look at the champagne poppers here, the reason why it works is there's a little bit of gunpowder right here in the stem, and this little piece of cotton thread provides enough friction to ignite the gunpowder, which then causes an equal and opposite reaction and causes the confetti to burst out. Hello again, folks. I'm Mr. Luchwager, and in part of this video that we're going to, you're going to view today about different careers from Upward Bound, I'm going to talk about how I became a teacher. I graduated in high school over 20 years ago from a really small community. It was Abbotsford, Wisconsin. There were 44 kids in my high school graduating class, and one of them was my twin brother. So I felt that it was best academically to start at a smaller university than attend a large one like University of Wisconsin-Madison. So I started at UW-Stevens Point, and my initial major was paper science. And as a freshman coming into the paper science program, usually you end up taking anywhere from 18 to 20 credits your first semester. To put it in perspective, most freshmen take anywhere from 12 to 16 credits. So the workload was quite a bit more than pretty much any other major that I was aware of at UWSP. And the reason why I picked it paper science is that I really enjoyed chemistry and physics and the other science and math classes that I had, and I really was inspired by some of the teachers that I had to continue into that. Also, one of the things is that UW Stevens Point was one of the only one of like 9 universities in the nation that had a paper science program. So as I progressed through my freshman year, everything was going well. And then beginning of my sophomore year, I had interviews for internships. And one of the places that I really, really wanted to go for my internship was down to a mill down in the state of Kentucky. So I prepared for that and interviewed, and as a sophomore, or going into my third year of college actually, I had a 9-month-long internship down in Hawesville, Kentucky. I worked in a bleach pulp mill, and I really enjoyed the experience. The people were great. It was some interesting work, but honestly, I'm glad I had the internship when I did, because then I realized that paper science really wasn't what I wanted to do. So afterwards, I returned back to UW Stevens Point, and I ended up changing my major. I actually went undecided for a while, or undeclared, and then I ended up changing my major to history. And I kept a lot of my science credits by going with a minor in broad-field natural science. Eventually, I graduated with a bachelor's of science in history and a minor in broad-field natural science in December of 2003. Got out of school, couldn't find a job. The Great Recession was going on. Ended up moving to the western part of the state of Wisconsin. And I decided after a while I couldn't get a job that I wanted to go back to school. And I wanted to be a teacher. And there were a couple of reasons why I decided on education. Number one was the fact that pretty much everybody in my life that I had looked up to, other than family and close friends, were teachers. And I felt that I could pass on that torch and pass on the love of learning to other people. Also, when I was down on my internship, my immediate supervisor was talking to me one day, and he's like, "I don't understand why you're going into paper science. This is not a program that you are cut out for." And I, being that, I had already invested 2.5 years into the program, I asked him why. And he said, "I can't see you doing this the rest of your life." He's like, "You should be somebody, or you should be in a different career field, something like being a teacher. And I could see you being a teacher and being a really great teacher and having an impact on a lot of people." And that really hit home, and that made me really want to reevaluate what I was going to school for. So what I decided to do when I went back to school at UW River Falls is that I wanted to continue with the science part. So I really worked on my science credits for my broad-field natural science, and through the 3 years I was there, I ended up getting certifications in broad-field natural science, chemistry, biology, and earth science. And I was certified to teach these at the high school and middle school level. And in fact, I really enjoyed my time at River Falls, and one of the things that I wish I would have been more aware of when I was in high school is going out and visiting those colleges and becoming aware of what the experience is like on each part of the campus. If I had to do it over again and get a original bachelor's degree, I would have gone to UW River Falls instead of going to Stevens Point. So make sure that when you go through and you start looking at higher education, you really evaluate where you want to go and why. I was pretty lucky during my time at UW River Falls. I was able to have a lot of unique experiences that I don't think I would have had other places. One of the things is at River Falls is not only having excellent college professors and having some excellent courses there, Once I got accepted into the education program, I was able to do some pre-student teaching at large inner city schools and learn about the diversity that's in these school communities. And I think that was one of the most enjoyable things I had ever done in my college career, was to see these large schools in large urban areas. Also, I got to teach in just generally larger schools. I did my student teaching at Hudson High School and Hudson Middle School, and it's a larger community in the western part of the state. And to be able to work in a larger district like that and see all the different experiences that students have is one that's pretty unique, especially when you grow up in a small rural community. Eventually, when I did get my teaching certification, I ended up teaching in some pretty small rural districts. But one thing that I've noticed is that it doesn't matter where you teach. The needs of the students are all the same. And those needs don't change from student to student and area to area. So I've been very fortunate to be in some excellent districts. And that is my path into becoming a teacher. It was a little bit longer than most. It was a little bit more unique than most. But it's one that I wouldn't trade for the world.